Hi.
Don't worry about the mess, we are moving.
AFCI is a type of circuit breaker I saw nowhere else in the world during my travels but here in my own home. My breaker panel is filled with them, except I replaced the one for my room here with a basic breaker because it kept tripping while I was working. So does AFCI breaker actually provide some vital protection, or is it just a scheme by the big circuit breaker to sell us unnecessary junk that trips for no reason, forcing us to buy more replacement breakers? To be honest though, I have tripped stuff in my room that were not even a fuse or breaker. Damn it. Oh no. So perhaps I can't blame the AFCI, but I need to know what it is and how it is tripped. Arc fault circuit interrupter. In Canada and the United States, AFCI breakers have been required in residential bedrooms, except for my room. Canadian Electrical Code has since 2015. So I've never been in a newer house or building. My house was renovated in 2020, that's why I have it. This is the one I took out. This thing is double the length of a regular breaker, so double the protection? The one I have is from Schneider Electric, a combination breaker, which means it's a regular circuit breaker combined with an AFCI, and it's a 15 amp breaker. It's interesting, both live and neutral feed into this breaker and leave from the other side. If I check the continuity, live disconnects, but the neutral stays connected. Anyway, it must act like a traditional breaker where you feed live to it from one side and power the room from the other side. And if the current draw is more than the trip current of the breaker, it'll trip open. I have a short here between live and neutral, and if I turn the power on, well, the breaker didn't trip because my short fused open faster than the breaker. How can I draw more current from it safely? I know! The breaker doesn't care about voltage, it just cares about overcurrent. So I'll use my power supply here to draw 40 amps through it at much lower and safer voltage. So now we just turn on the power and short the output. Ow! Or to avoid blinding lights, we turn the power off first, connect the output, then turn the power on. Come on, pop. Why is it? Come on, come on, come on, come on, come on, pop, 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 pop. I need a thicker wire. Ah! And that's why you pick a breaker with proper trip current to protect the circuits connected to it. Now, hopefully this wire can withstand the current. Damn it! Connect the wire first, then turn on the power. 1, 2, 3, 4, 5, 6, 7. Took almost 7 seconds for it to trip. That's a long delay. Even at 40 amps, it takes a while between overcurrent and tripping the breaker. Breakers trip with different delays during a high current event based on a time versus current curve plot. How in the world do you know how to follow such mathematical curvatures to protect our homes?
I use Brilliant. Our sponsor Brilliant has the best interactive lessons online. I've been tripping thinking about them.
I'm always happy to have Brilliant as my sponsor because I know you and I will both grow smarter through Brilliant's thousands of lessons in math, science, programming, AI, and especially data analysis content, where you can learn how to collect data, understand it, visualize it, and analyze it properly, all using real data sets from sources like Airbnb, Spotify, Starbucks, and more. Yeah.
All you need to do is to sign up visiting brilliant.org/electroboom and try them for free.
Because Brilliant is a learning app with hands-on problem solving, the most effective way to learn. You can build knowledge from ground up while being engaged in fun and interactive lessons that make you a better thinker.
All by just creating a daily habit of learning.
Don't just click on my link and get started for free, and you can enjoy 20% off Brilliant's annual premium membership forever.
In any case, I keep saying how important GFCI is. You know, it senses the imbalance of current between live and neutral, indicating the current going out of live is not fully returning to neutral. Perhaps it is passing through your body to earth, electrocuting you. So it pops open and saves you. Then why did we decide to bypass that and go straight to AFCI? Was arc fault much more important? Let's test it for ground fault. I've connected live and neutral to the breaker, and I'll connect earth through a 1 kilo ohm resistor to the live output. So, goodbye 1 kilo ohm resistor. It popped. Does it have GFCI? It doesn't say anything about GFCI on this, but it has it. What current does it trip at? Here is 22 kilo ohm for a bit more than 5 milliamps. Nope. 10 kilo ohms for 12 milliamps. Nope. 3.9K for a bit over 30 milliamps like RCDs. No. 3.3K for a bit less than 40 milliamps. No. Does it eventually pop? Doesn't look like it. 2.7K for a bit less than 50 milliamps. Hey, so it seems like if there is any ground fault protection, it trips at around 40 milliamps. But it pretty much saves your corpse from burning any further. So while the European RCDs trip at around 30 milliamps, this guy trips at 40 milliamps. It's better than nothing. Progress in North America for new houses. It has some complex circuit inside, but I can't find the datasheet talking about ground fault protection. Does AFCI provide ground fault protection? No, an arc fault circuit interrupter does not provide ground fault protection. Perhaps AI is hallucinating, or maybe it's a bonus function only this breaker provides. Maybe it's an unintentional side effect of AFCI. But what does an AFCI try to protect against? Do you have outlets at home with springs so loose that your power cord just falls out of? They can cause fire, because not only a bad contact means a high resistance hot contact, but also loose contacts under high loads can generate hot arcs. These events don't necessarily draw high currents to trip a regular breaker, but are hot enough to cause a fire. An arc fault circuit interrupter promises to detect these events and disconnect the power and protect you. Or at least that's the promise. Let's see if I can trip the AFCI. I'm gonna create an arc, popping a thin wire connected to the live and neutral outputs of the breaker, and we connect the power. Don't do this stupid shit. Oh, forgot to reset the brake. Well, it didn't pop. Apparently it wasn't archy enough for it. Perhaps because it was just a short pulse. We need something more continuous. So let's use my super dangerous, don't ever use it, microwave oven transformer. I create massive arcs from 2000 volt output. The wires are melting, but it's not tripping. Damn it. Oh, perhaps the issue was it was the output of a transformer. We need something right at the power lines. So this is just a single large inductor that draws 5 to 10 amps from the lines. Aren't these considered arcs? Why is it not entertained? I'm thinking the AFCI is looking at continuous current interruptions in the power line to detect loose contacts that might be arcing. An inductor tends to smooth out the current, so it might not look interrupty enough to the breaker. Let's just use an incandescent light bulb, a resistor that can draw half an amp from the power line that I can switch. Oh, I can switch this fast enough to create interrupty current. And yet there is no tripping. Perhaps the current is too small for it to be considered dangerous arcing levels. I know. This is a 250 volt 1 microfarad capacitor. Capacitors act like a short circuit for high frequencies. So as soon as I touch the line to it, it draws a ton of current trying to charge. Perhaps the capacitor charges extremely fast and the pulse of current is too short to trigger it. Or maybe the breaker is broken. It has a test button on it. Let's see. Nope, it's good. I think we need a bigger load. Oh, I know. Do you remember my 6,000 watt resistor? On 240 volt though, on 120 volts it's only 1500 watts, which is the maximum load I can put on these circuits anyway. So here it is, almost running 12 amps and it doesn't trip. But what if we do that? AFCI, come on, the wire is getting hot, it's gonna burn and you're still not going to trip? If you're not tripping for this, what will you be tripping for? I'm burning my finger here, man. Come on, trip. Ah! Let's do it with a better contact. This is a loose contact, isn't it? This is odd though, because my wires are hot and melting. I don't understand. There you go. It desoldered. It was that hot. Let's run a timer. Maybe similar to a regular breaker, at different current, it trips at different times. Okay, this is rubbish. I've been running it for more than 3 minutes and nothing. For sanity check, I brought my heater to connect it to another outlet that is on a different AFCI to see if it behaves the same. Here we go. Don't try the stuff I do. So it's not the AFCI, it's the type of my arcs for some reason doesn't excite the AFCI breaker enough. Come on, what do you want from me? Somebody has to send me specs to the arcs that triggers AFCI, for God's sake, it's driving me crazy. I couldn't take that massive thing with me around the world anyway to test AFCI. I need to create sparks in a small, like salt water. I'm gonna pour highly saturated salt water onto some contacts, like this. Come on, pop! Damn it! Pop! It's spraying everywhere! No! I had to stop it myself. At some point, we need to ask ourselves, what are we really protecting against? Perhaps if I had much larger capacitor to create massive spikes of current, it would trigger this. Let's go to Lee's Electronics. Components. These should do nicely. Around 60 microfarad and around 200 microfarad, 330 volts. This should draw 10 amps on my 120 volts. And I bought this one to draw around 5 amps for 240 volts. So I can use these all around the world to test for AFCI. And yeah, I bought a power potentiometer too, because my low power ones kept blowing up when I was testing ground fault. 200 microamps. Of course, if we directly connect it to power, it draws close to 10 amps. Not enough to trip the breaker, but if we keep charging and discharging it, oi! Oi! It tripped! Let's just try it one more time to make sure I'm not crazy. The damn thing is not consistent. What if I combine the giant capacitor with my massive inductor to create the largest arcs ever? I put the smaller 60 microfarad capacitor parallel to my super large inductor as the load for the breaker. This better work. Oh my god, the stupid inductor is loud. Ouch! It tripped! Trying again. It is tripping! Again! Tripped! Again! It is tripping consistently. Why the hell is it so hard? Trips right away now. This type of load is like an AC motor. I guess they make the largest and longest arcs that trips the AFCI. See, a capacitor and inductor, when disconnected from the power lines, create these massive oscillating voltages that last for a long period of time that create long and hot arcs. Maybe the AFCI is trying to protect against that. Although I had some minor success tripping the AFCI with a single capacitor, but I can't take this around the world. Actually, what is the magic of this test button that I couldn't repeat here easily? Is it just connecting a resistor like a GFCI testing? What if we put both capacitors in parallel? The higher current should hopefully help. Oh, it tripped! Try again. How consistent is it? Tripped again. What is going on? See, it doesn't trip like this, but when I do it like this, it trips. Try again. Doesn't trip like this. Trips like this. Oh man, this has a computer in it that looks for certain timing or something.
This thing is very hard to trip, but it does trip for some specific hot arcs and can save your home from fire. So install it, or even better, replace those loose garbage outlets you have at home. In the meantime, I'll take my giant capacitors around the world for test for AFCI in addition to GFCI. So stay tuned and subscribe.